right, good afternoon. I'm Austin Federa. I am one of the 3 co-founders of the 00 protocol. And 00 is a purpose-built network for high-performance distributed systems. And when we say network, I don't mean layer 1, I don't mean layer 2, I don't mean anything even blockchain related initially. I mean a physical infrastructure network. So physical fiber on physical cables running under oceans, over mountains, beneath cities. And this is a deeply physical network. We are talking again about cables that sometimes sharks go after, not as much anymore, but they used to go after them more, and physical infrastructure devices. So this is an OSI layer 1, 2, and 3 network. It's far lower down in the stack than pretty much anything in crypto operates except for like Bitcoin miners. And this network is powered under the hood by a ton of cryptographic principles. It is powered by blockchain, and it is run by multiple independent contributors. But we'll start off with kind of the first question of why do this at all? And so this is a graph of the internet we all know and love. What you see from this, though, is there's 2 properties of the internet that the internet is particularly bad in. So this is a track over about 24 hours between LA to Singapore. And the variance in the red and orange is what's known as jitter. This is how much the ping time varies from moment to moment across a system. So if you grew up playing video games, you know you literally live and die based on your ping time. The jitter is a measurement of how much that ping time changes. And so what you see is the public internet, well, it's a marvel of reach. I can reach any server anywhere in the world for like $40 a month. That's incredible. It is not built for performance. It's built for cost reduction. And so what you see here is you can actually see right around the 1600 mark when the cable system that this particular ping test was being routed over changed. And it moved to a worse system. And it went up from about, let's call it 300, 250 milliseconds up to more of a base of 350 to 400 milliseconds. And then you can see later in the day when it moved back down to that slower cable, faster cable system again. This is totally fine if you're watching YouTube or if you're sending telegrams or iMessages. If you're running a high-performance global network that's carrying financial transactions, AI inference, and all those other sorts of activities, this really isn't suitable. And so this blue line that you see at the bottom, which doesn't even look like a scatter plot, but it technically is, that is the 00 network. That is consistent 24/7, 365 with functionally zero jitter and a very known latency amount. This is the type of thing that we see all the time in companies like this. So you may think of these as all public internet infrastructure companies. None of these use the public internet for the majority of their work. Even eBay has a global private fiber network for moving data around because the public internet is too slow for their needs. So when we think about this question, it's like, why is Facebook involved in private fiber infrastructure? Well, it's because the public internet is too slow. And if it's too slow to show reels to people, so you keep scrolling so they keep showing you ads, why are we using it in blockchain for all financial infrastructure, all transactions, and all data? And this is the journey that every successful software system has been on. Facebook started ostensibly in a dorm room, but then eventually you move on to they built their own servers. They built their own server racks. They built their own data centers. Then they built their own subsea cables eventually to increase their TAM. They had to wire up the Philippines so they could show people ads. And crypto has finally reached the point of adoption where we're actually starting just barely and just in a few areas to truly compete with traditional finance. But crypto today is too slow and too unpredictable to be able to do that. And the same types of problems that are affecting the financial side of crypto also affect the AI side of it. And so we have a training problem and we have an inference problem with AI data workloads as well. Let's start with the training problem because that's one of the more fun ones. What we have today is we have data stored largely in centralized databases and vertically integrated cloud providers and other types of providers. And we need to get that data to where the GPU farms actually are. So look at something like CoreWeave. They built a huge GPU farm and they said, okay, great, we're ready to take customers. The customers said, where do we stick all our training data? They said, okay. They went back and they built a bunch of storage arrays bolted onto that data. They said, great, how do we move like 10 petabytes of data from an S3 bucket into your system so we can actually access and train in your GPUs? And they said, oh, okay, we got to go build a lot of fiber infrastructure. And unlike the other two, fiber infrastructure, it's physical infrastructure in the ground. Governments have to permit it. You have to dig holes in the ground. It takes months, if not years, to install a lot of this fiber capacity. And so when OpenAI comes in and they're building a data center, one of the first things they're doing after they figure out, can we get enough power, is they figure out right-of-ways and access to put in fiber to link all these different data centers together. And the 000 network, being this global network that has multiple contributors to it, is able to be sort of this fabric layer that allows data to move more quickly than the public internet. The second problem is the inference problem, which we don't necessarily think of as a problem in the traditional sense, but most data that you're consuming from a centralized Web 2 entity, it comes from close proximity to you. I live in New York. If I'm accessing Google Docs, that Google Doc is in New Jersey. If I'm watching Netflix, that's coming from a server in New Jersey. The distance nowadays between a Web 2 consumer and a Web 2 service is actually not that geographically large in most of the world. But all these AI data centers, the one limiting factor in where you build them, it's not zoning, it's not permitting, it's where can you get enough electricity. And you can't get enough electricity in the areas where we have most data centers today. They're in rural parts of the country. They're in areas where the power grid allows that type of expansion. And so when we think about the data movement problem, Claude's got to pull all your code off your laptop and send it up somewhere. And it's not going to a data center in New Jersey. It's going to a data center in Lubbock, Texas. It's going to all of these places that historically don't have great connectivity. And so when we think about the decentralized problem of AI, it's not just the training, it's not just all these other components, is that we have to move much more data as a society than we've ever had to move since the advent of the cloud. And that's a whole new problem for crypto, it's a whole new problem for AI, and it's something that the 000 network is really in part built to address. So if you look at this, this is a map of the world, as we should be familiar with. And this is the 000 network today. If you go to 00.xyz/dashboard, you can see this whole network in real time because it's all powered by blockchain under the hood. It's about 8.8 terabits per second of global connectivity and capacity. But one of the really cool things about this, oh, look, it moves. Great. One of the really cool things about this is it's a contributor network built by 15 independent contributors. This is the first high-performance fiber network in the world run by multiple independent contributors. So each of these contributors, they admin their own boxes, they admin their own lines the same way that each NEAR validator is run by a different independent entity and not by the NEAR Foundation. We've taken this approach that for so long has been the underpinning of blockchain compute, and we've now applied it to connectivity and bandwidth. And so we have censorship resistance. We have alternative pathways into systems if one provider misbehaves. We have staking on link rewards to make sure that if that link misbehaves, there's a financial repercussion for it, just like slashing in blockchain. And so the entire purpose of this is to allow these networks to exceed the performance of what the public internet is capable of. And that's holding back a ton of innovation today in the blockchain space. Our first use case for this was the Solana network, where we have about 50% of validators running on it today because they built a validator client, two validator clients that were limited by the speed of the public internet. And instead of saying, let's bring the cluster down to just a few nodes located in a few data centers, it was, can we keep this thing global and can we exceed the speed of what's possible on the public internet? So again, this is a layer 1, 2, and 3 in the OSI stack, very low level down network. This is blockchain agnostic. You can run non-blockchain systems on this as well, but we think that the crypto community, where I come from, particularly understands the importance of this in a way that traditional software companies don't yet, or at least they have different needs and requirements from. So what does this look like? We have core contributor teams, we have network contributor teams, we have users that are all accessing it, and what we build is that software protocol that meshes it all together. One of the coolest things we can do on this network that you can't do on the public internet is multicast data. And so multicast is this really cool system where it's hardware acceleration for packet replication. If you have one validator in New York and you have 1,000 validators in London, in a normal model, you're sending 1,000 copies of the data across the Atlantic. With multicast, you send one copy and that data is replicated as close as the endpoint as possible. This is not possible on the public internet. The technology simply is not supported. It's baked into the 000 network, and this is one of the main features because what is blockchain doing? Sending a lot of the same data to a lot of different nodes all over the world. And so By using this, we've been able to reduce, I'll skip through because we're running a little bit on time here, reduce latency and block propagation even within Europe on Solana by over 100 milliseconds. We've also been able to reduce the bandwidth usage on the shred propagation system by 99.96% using multicast. This is approximately the difference in water between these two pictures. So what we're really looking at here is a whole new era for high-performance distributed systems, a whole new era for distributed and decentralized AI, and the idea that decentralization doesn't have to be a clutch, doesn't have to be something you pay extra for because you believe in the value of these systems. It can be something that can make these systems even more competitive. So if you're interested in learning more, 00.xyz, lots of info there, and I'll be around later as well. Thank you.